You can use the inverse property anytime you have an exponent raised to the log with the same base. So if I have 5 raised to the log base 5 of x, since my bases match, that's just x. Same thing is true for logs. So if I have log base 5 of 5 to the x, that just equals x. There are two strategies for solving a log equation. One is to change it from log form into exponential form. We know that natural log of x equals 7 can be rewritten as log base e of x equals 7. We can solve this by changing it from log form into exponential form. So e to the 7 equals x. So x equals e to the 7th. The other method is by exponentiating both sides. So natural log of x equals 7. We can rewrite it as log base e of x equals 7. Now, if we raise everything to the e power, so e to the log base e of x equals e to the 7th. Using the inverse property, we know that e to the log base e of x is just x, which means x equals e to the 7th. Either one of these solutions will work in solving this problem. Once again, we can use either method. Method 1 is changing from log form into exponential form. So log base 3 of x equals 4 becomes 3 to the 4th equals x, which is x equals 81, because that's 3 to the 4th. Method 2 is exponentiating both sides. So we start with log base 3 of x equals 4. Now, since it's log base 3 of x, we'll take 3 and raise everything to that power. So 3 to the log base 3 of x equals 3 to the 4th. Since we know, using the inverse property, that we have 3 log base 3 of x, we can that just becomes x. And then 3 to the 4th is just 81. In order to solve this, we first have to isolate the exponent, which means we need to divide both sides by 2. When we divide both sides by 2, we get 5 to the x equals 16. Now we can use either method. Method 1 is changing from exponential form into log form. So when we change it from exponential form into log form, it becomes log base 5 of 16 equals x. Now, in order to solve for x, we have to use the change of base rule. So x equals log of 16 divided by log of 5. When we put that into our calculator, our answer is approximately equal to 1.723. Now, if you didn't want an approximate answer and you wanted an exact answer, you could leave the problem at this stage. Now, the other method involves taking the log of both sides. Both methods, you must first isolate the exponent. So let's return to the original problem. We have to divide both sides by 2. So we have 5 to the x equals 16. Now, at this stage, we want to take the log of both sides. Since the base is 5, it's going to be more efficient to take the log base 5 of both sides. So we'll take the log base 5 of 5 to the x equals the log base 5 of 16. Now, as you notice, the bases match, so the left side just becomes x, and the right side remains log base 5 of 16. Using the exact same change of base formula that we did over there, we can solve this problem to get x to be 1.723. Once again, there are two methods, but before we can use the first method, we must isolate the exponent. So we're going to add 7 to both sides, and we get e to the x equals 30. Now, if we change it from log form into exponential form, we would write log base e of 30 equals x. And as you remember, log base e is really the natural log. So we rewrite that as the natural log of 30 equals x. Now the natural log of 30 is an exact answer, but if we want to do an approximate answer, we would plug into our calculator the natural log of 30, and we would get approximately equal to 3.401. Now if we use method 2, we start with the original problem, and once again we must isolate the exponent. So we add 7 to both sides. So we have e to the x equals 30. Now, because e is our base, we would take the log base e of both sides, which is in fact the natural log. So we take the natural log of both sides. So we have the natural log of e to the x equals the natural log of 30. Now remember, the natural log of e to the x is just x because the bases match and we use the inverse property. So x equals the natural log of 30. So x is approximately equal to 3.401. Now you practice using the methods that we just taught. The answers will be on the following slides after you practice. To solve this problem using method 1, we first have to isolate the exponent. The way to isolate the exponent in this situation is we have to subtract 4 from both sides. So we have 6 times 2 to the x plus 5 equals 7. Now we need to divide by 6. So we have 2 to the x plus 5 equals 7/6. Now we can change this from log form into exponential form. So we have log base 2 of 7/6 equals x plus 5. Now to isolate the x, we must subtract 5 from both sides. So we subtract 5. So x equals log base 2 of 7/6 minus 5. Now this is our exact answer. If we want an approximate answer, we must use the change of base rule to approximate. So we would do x equals log of 7/6 over log of 2 minus 5. Our approximate answer would be, I have to use my calculator, the final answer would be negative 4.778. To solve the exact same problem using method 2, we still have to isolate the exponent. Remember, we need to subtract from 4 both sides. So we have 6 to the 2x plus 5 equals 7. Then we must divide by 6. So we have 2x plus 5 equals 7/6. Now that the exponent is isolated, we can take the log of both sides. Since our base is 2, we're going to want to take the log base 2 of both sides. So log base 2 of 2 to the x plus 5 equals log base 2 of 7/6. Now, remember, since our bases match using the inverse property, we are just left with the exponent. So we have x plus 5 equals log base 2 of 7/6. Now we can subtract 5 from both sides. So we have x equals log base 2 of 7/6 minus 5. Once again, that's our exact answer. If we want an approximate answer, we have to use the change of base rule. So x equals log of 7/6 divided by log of 2 minus 5. When we put that into our calculator, we end up with negative 4.7776, which rounds to negative 0.4778. Now, in order to solve this using the first method, we can't do anything until we have only one log on the left side. So since we have addition, we know that when we add logs, if we're going to condense them, we need to write it as multiplication. So we have log of x times x minus 9 equals 1. Now, we have a single log, but before we do anything with that single log, let's distribute. So we have log of x squared minus 9x equals 1. Now, using method 1, we would now at this stage, since we have a single log and number, we would want to change it from log form into exponential form. Since there is no base, we know the base is 10. So we're going to change this from log form into exponential form. So 10 to the first power equals x squared minus 9x. Now this is a quadratic equation. The way we solve quadratic equations is we isolate the quadratic, we set it equal to 0. So we're going to subtract 10 from both sides. So we have 0 equals x squared minus 9x minus 10. At this stage, we need to factor. So our options for 10 are 10 and 1 and 5 and 2. Well, the only numbers that will multiply to get negative 10 and add to get negative 9 have to be 10 and 1. So we have x minus 10 and x plus 1. Now we can tee it up. We have x minus 10 equals 0, x plus 1 equals 0. So x equals 10 and x equals negative 1. However, since this is a log equation, we must check to make sure neither of these equations make our logs negative. Well, when we plug the 10 back in, we see that we're positive. So 10 in fact works. However, when we take the negative 1 and we plug it back in, we end up with log of negative 1, which we cannot have. So x equals negative 1 is an extraneous solution. So x equals 10 is our only answer. We will solve the same equation that we just did using method 2, so you can see the other method. We still have to start the same way. We must combine to make one logarithm. So since we have a plus, we know that when we condense logs when they're added, that becomes multiplication. So we have log of x times x minus 9 equals 1. We'll distribute. So log of x squared minus 9x equals 1. Using method 2, we exponentiate both sides using the base that is the log. So in this case, since there is no base written, we know it's log base 10. So we'll say 10 to the log of x squared minus 9x equals 10 to the first power. Now, using the inverse property, the 10 and the log undo each other, and we're just left with what's inside the log. So we're left with x squared minus 9x equaling 10 to the first power, which is just 10. Now this is a quadratic. The way we solve quadratics is we set them equal to 0. So we have x squared minus 9x minus 10 equals 0. So as we know, we need to factor this. The only options for 10 are 10 and 1 and 5 and 2. Well, the only one that are going to result in a negative 10 and a negative 9 is negative 10 and positive 1. So this factors to x minus 10 and x plus 1 equals 0. We can tee it up. We have x minus 10 equals 0, which means x equals 10, or x plus 1 equals 0, x equals negative 1. Once again, this is a log equation, and with log equations, you must check to make sure there are no solutions. The solutions work. So when we plug 10 back in, the log is positive, which is good. So 10 works. When we plug negative 1 back in, unfortunately, we end up with a negative log. We cannot have a negative log. So negative 1 is an extraneous solution. Our only solution is x equals 10. Now it's your time to practice. Solve these two equations using either method to find the answer.